So this video is going to be going over how to actually perform calculations with the unit moles. In order to do this, you're actually going to need this handout, which was given in class. Alright, perform calculations with the unit moles. And if you recall or look in your handout, you'll see that this top section right here is actually X'd out. So we're going to skip all of that and just jump right to using the moles. Alright, before we actually get into it, you'll see that I'm going to jump around here and there a little bit. If at any time you need to pause, stop, whatever, do so. Okay, so using the unit mole, you'll see that this one says MOL. Alright, for some odd reason the abbreviation for mole is MOL. Alright, I know it's just one little letter, but that is the abbreviation. Be familiar with it. Now let's consider similar problems just using the unit moles rather than dozen. That part is actually pertaining to the first portion which we had skipped. Okay, so let's just preface all of this by saying that the unit mole is basically a unit for amount, much like 1 dozen is equal to 12, alright, or a ream is equal to 500. We can say that 1 mole is equal to 6.02 times 10 to the 23rd. Okay, another example that's kind of a larger abstract number is actually 1 Google. Alright, you guys are probably used to Google as a search engine, but in actuality it's actually a unit for amount. It's actually 10 to the 100th power is 1 Google. Alright, so if you take a look, because we can set an equivalency, we can create conversion factors. Alright, so 6.02 times 10 to the 23rd units equals 1 mole. Alright, as a result, you can get two conversion factors for them. What are they? First one is going to be 1 mole over 6.02 times 10 to the 23rd, or the reverse of that, 6.02 times 10 to the 23rd units over 1 mole. Okay. Now sample sets. When we work through these sample problems, I'm actually going to jump right down all the way to the tip section. Alright, so when we look at the tip section, you'll see 3 things to cover. First thing, clearly identify given, known, and unknown. When trying to determine which conversion factor to use, always remember that the units that you're canceling go diagonal, and the units you want to go to will be on the opposite side. Do not hesitate to map out which units you need to go to. This will be especially helpful later for stoichiometry, which is the next chapter. Okay, so backtracking here. Determining that a sample of dinitrogen pentachloride has 4.39 times 10 to the 25th molecules, how many moles is this equal to? Okay, first thing you want to do is figure out the substance. Alright, dinitrogen pentachloride, formula for it is N2Cl5. Alright, once you have N2Cl5 figured out, you can see that it's a molecular compound. So molecular compounds, the smallest thing that is a molecular compound, are called molecules. Alright, we went over that before in class. So let's take a look. Our conversion sequence is going to be as follows. You're going to start off with molecules of N2Cl5, and then we're going to convert straight to moles. How can we do this? Well, look back here, up here at our two conversion factors. Okay, if we know that 1 mole is equal to 6.02 times 10 to the 23rd units, in this case being molecules, we can convert between the two. Okay, so first thing you want to do is set up your T-chart. In the first column, you're always going to put your given. Alright, in this problem when you read it, it says we're given 4.39 times 10 to the 25th molecules. So in the first column, the given information is 4.39 times 10 to the 25th molecules of N2Cl5. Now we have molecules up here, so we have to get molecules down here. Alright, and we want to convert 2 moles. So up here in this top section, we're going to have moles. Alright, so you're going to have moles here, and then you're going to have molecules down here. Now remember, we have to make sure that two things are equal to each other. How do we make them equal to each other? Well, you set 1 mole is equal to 6.02 times 10 to the 23rd molecules. Alright, now how to enter this in a calculator. It's been a while since we did calculations, so what I did was pull up a online scientific calculator to go over exactly how to enter it in. Okay, so let's clear everything and start off with 4.39, and instead of doing times 10 caret 25, I'm going to use, in this case, this E button for those of you with scientific calculator TI-89 or TI-83. It'll be the second function, and then the comma button, which is the EE function. So 4.39 E, and then all you have to do is enter the exponent 25 right there and see how it comes out. 4.39 times 10 to the 25th. Okay, we divide by the bottom number, which is 1, so we can skip that. Multiply by the top number, which is also 1, so we can skip that. Divide by the bottom number being divided by 6.02. again using the E button, not times 10 caret or anything like that. And here the exponent is 23, so it'll be E23. Okay. Once we have that set up, we can hit the enter button. You'll get this large number. Now, going back, remember sig figs. All conversion factors are infinite in terms of their sig figs. Why? Significant figures deals with uncertainty. Well, there is zero uncertainty. There's absolutely no uncertainty when we say that 1 mole equals 6.02 times 10 to the 23rd. So all conversion factors, because they're equivalencies, have infinite significant figures. So that leaves only the first given starting number. Well, if you look here, this is an explicit number. Why? Because we have the decimal written. Alright, in explicit, you start with your first non-zero, count everything to your right. So here we have 3 significant figures. So this whole number is going to be rounded to 3 significant figures. 7, 2, and the 9. The 2 here becomes a rounding digit, keeping this 9 a 9. So your final answer is going to be, see if I can get this right. Entered in, it'll be 4.39 E25 divided by 6.02 E23 equals 72.9 moles. Why? Because the molecules cancel out and you're left with moles. Okay, so specifically we want to say that it's moles of N2Cl5. And let's get those subscripted as such. And there we go. So it's nicely done on one line. So this is your final answer for that first problem. Okay, so let's apply again. Another practice, another problem. How many atoms of hydrogen are present in 55.21 moles of hydrogen gas? First thing you have to know, hydrogen gas, because it's a diatomic, is going to be H2, not just H. Okay, and it's asking for atoms. Now, if you recall, typically for an element, the smallest representative particle is going to be an atom. But with the diatomics, they're actually going to be molecules. Molecules themselves are made of atoms. So again, very key point, back to the tips. Clearly identify your given, known, and unknown. Okay, we're given moles of hydrogen gas. We want to know atoms, not molecules of hydrogen. So our conversion sequence is going to be as follows. It's going to be from moles of H2 to molecules of H2, and then finally to atoms of H. Okay, so set up the T-chart. First thing that goes in is going to be your given information. 55.21 moles of H2. We have moles up here, so we put moles down here. Alright, so let's convert that. We have moles down here. We're converting to molecules. Put molecules up here. Again, we have to make sure that the numbers are set so that the top and the bottom values are equivalent to each other. We know that 6.02 times 10 to the 23rd molecules is equivalent to 1 mole of H2 of hydrogen 2 molecules of hydrogen gas. So right now, if we stop the calculation here, we'll cancel out moles and we're left with molecules. But that's not what we want. We want atoms, so we have to get rid of molecules. So what do? We put molecules down here and we want to convert to atoms. Okay, so what we're going to do is set atoms on top, molecules on the bottom, and put numbers in them so that they're equivalent to each other. It's 2 atoms of H for every 1 molecule of H2. Okay, so again, if you want to look at how to calculate this, scroll up, clear everything, and start off with 55.21. Again, down here, divided by 1, we can skip that, times 6.02. I'm going to use the E function here, E23. Okay, divide by 1, skip that, multiplied by 2. Okay, so if you take a look here, this right here on the online calculator shows the exact calculation, and it is accurate. It's going to be 55.21 times 6.02 times 10 to the 23rd times 2. Okay, get an answer. It's going to be a large number. Okay, again, don't write the whole thing out. You have to round it to significant figures. Again, looking back over here, this is a conversion factor, so that's infinite, and this is a conversion factor, so this is infinite. Therefore, you look back at your given, that's 4 significant figures. Here in the calculator, we have an explicit number because there's no decimal present. Okay, so this calculator is showing a number with 1, 2, 3, 4, 5, 6, 7 significant figures. Too many. We only need 4. So I'll take the first 4. 1, 2, 3, 4. That means this 2 right here becomes a rounding digit, keeping the 7 a 7. Okay, therefore your final answer is going to be 6.6 647 times 10 to the 25th atoms. How did we get that exponent? Simple. Start here. In order to get the decimal point to this spot right where this cursor is, okay, I had to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 times. So it's 6.647 times 10 to the 25th atoms of H. Why? Because moles cancel out, molecules cancel out, and you're left with atoms. Okay. Hopefully you're getting the hang of this. Alright, so that leaves the third problem with 9.22 times 10 to the 25th individual hydrogen atoms. How many moles of hydrogen molecules can be made? Okay, so we're given atoms and we want moles. Now we know that hydrogen, because it's a diatomic, is going to be H2. The representative particle of H2 is going to be a molecule. Okay, so we know we can relate the representative particle of molecules to moles, but we're actually starting off with atoms, so we have to find a relationship between atoms and molecules. How do we do that? You look at the formula for hydrogen gas. We know it's going to be H2. Alright, so we know we can start off with 9.22 times 10 to the 25th atoms. We have atoms here. We're going to put atoms down here, and we want to convert. First conversion is from atoms to molecules. So we put atoms down here, and let's see if I got this right. Atoms down there, lucky me, and I want to put molecules up top, molecules up there. Now the numbers that go in, it's going to be 1 and 2. Why? Again, make them equivalent. One molecule of H2 has 2 atoms of H. Now, if we stop here, we are simply left at molecules, but that's not what we want. We want moles. So what do we have to do? One more conversion. We have to get rid of molecules, so I'll put molecules down here. Okay, whoops, so too much. Let's see if that works. No. You guys get the point. So we have molecules down here, and we're going to convert 2 moles, so I'll put moles up top here. Alright, therefore, one more time, going over the calculation for this. Flip down here, clear everything from the calculator, and we're going to start off with 9.22 E22 divided by 2 divided by 6.02 E23. Okay, and it comes up with this weird funky thing, but it is in actuality correct. Why? Because if you look at this, math skills has been a while, I believe it's called complex fraction, you'll see that the numerator is divided by the denominator, which in fact the answer for that becomes the numerator for the next division problem here. Okay, so it's 9.22 times 10 to the 25th divided by 2 divided by 6.02 times 10 to the 23rd. You get, again, some long number, but sig figs. Infinite sig figs for this conversion factor here, infinite sig figs for this conversion factor here, leaving our first given. Our first given only has 3 significant figures, so let's round this to 3 significant figures. Ladies and gentlemen, this is an explicit number, so you always, regardless of explicit or implicit, start with your first non-zero. So in fact, a 7 is our first significant figure. We need 3. That's 1, 2, and 3. This next 7 right here becomes the rounding digit for this 5, so it pushes the 5 up to a 6. Your final answer is going to be 0.0766 moles of H2. And if you want to express that in scientific notation, it'll be 7.66 times 10 to the negative 2. And put that as a superscript. And then your unit will be moles of H2. And that's your final answer. Hopefully that does help you out in terms of how to do molar calculations. Guys, these molar calculations, once you get the hang of them, are not bad at all. Okay. Otherwise, you'd have additional practice down here. You can take a quick scan at the video to see roughly how many boxes or columns you should have. Alright, and you should be working on these for practice. Alright, hopefully this video was helpful. Alright.